Okay, 5.2 is also pretty easy. These are all building blocks. They're all going to be building blocks and you need each piece of them. I was just doing this with my grade 12s the other day. We were building on our unit circle because we need all those pieces to do the more complicated stuff. Okay, so a function is a special type of relation. So it's a special type of relation. So there's a very special type of relationship here when we talk specifically about functions. So yesterday we were talking about set 1 and set 2, and I used some words like independent and dependent variables. We're going to get to those as well. So domain is your set number 1. Okay, and your range is your set number 2. So that's from yesterday, right? So now we're giving them fancy names. Yesterday it was set 1 and set 2, and now we're giving them really specific fancy names. And domain and range you are going to use in all of your future math classes. Okay? All right, so if we were to identify the domain and range of this group here. Okay, so when we list the elements, we do not repeat an element that occurs more than once in a set. Yes, Rahat?
So the 1, 2, 3 for the numbers would be the domain.
Let's call this.
And then the thingies, like the
Okay, yeah.
That would be the range.
Yeah.
And then if I'm correct, then the arrows will be the function.
Not yet. Not yet. We're not there yet. We got to identify domain and range, and then we're going to tell you something specific about what makes it a function or not. So let's slow down for a second. So on part A here, my domain, so I start with a D and then I put a colon. And because we're going to make a list of numbers, we're going to use our fancy brackets again. So we're going to say the domain is made up. Oh, geez. Where's my fancy bracket skills? There we go. That's a bad fancy bracket. It's like I started, then I stopped. Okay, so we're going to open up our list. Yeah?
We can't see it.
How come you guys can't see it? Oh.
The giant hydrogen.
Oh. Silly window.
The giant hydrogen ball.
Heard you.
Keeps our Earth alive.
What? What?
Oh, I don't.
Better? A little bit better? What? I feel like this is really dark. And that's a little bit brighter. Okay, so we're gonna list the things that are in the domain. So we're gonna list the things that are in set 1. So this is gonna be our numbers. So this is gonna be 1, 2, 3, and 4. And I'm gonna close it with a fancy bracket. Oh, that's a way better fancy bracket. So this is for part A. So what's in the range? What's in the range for part A? Remember that range is our set 2. So it's going to be all the modes of transportation here, right? So our range, and we're going to set it up the same way. Fancy bracket. So R colon fancy bracket. And we're going to just list the things in our range. So bicycle, a car, motorcycle, a tricycle, and a unicycle. Ooh, and I write really crookedly, I realize. And I'm going to close that with fancy brackets. So each element, remember that this is an element. So each element is separated by a comma. And when they're numbers, we put them in ascending order. And here we did put them in alpha order as well. Okay, so for part B, what's going to happen? Because now what is set 1? Set 1 becomes the mode of transportation. So now what's my domain? It's this stuff, right? So my domain is fancy bracket, bicycle, car, motorcycle, tricycle, unicycle. And now my range, so just because they switch places, all of a sudden that means something very different. So my range is going to be 1, 2, 3, 4. And again, when you're writing them as a list, you do not need to repeat them if they repeat. How many wheels does a bicycle have?
3, no, 2.
2. And how many wheels does a motorcycle have?
2.
Also 2. So 2 is used twice, but we don't have to write it down multiple times. It's like we're writing essays here. Whew. I promise it will get better. We're going to get to numbers soon. So this is just the part of identifying domain and range. We haven't even talked about functions yet, but we need to know stuff about domain and range before we can do functions. Are you guys good if I flip the page? Okay. So what is a function? So a function is a special type of relation where each element in the domain is associated with exactly one element in the range. So let me say this in more, I say it in the next bullet. You cannot have repeating domain values. You cannot have anything in your set 1 repeat. Okay? All functions are relations, but not all relations are functions. Whew. Make sense? No? Okay, let me. You didn't get the last line? That's the confusing line. All functions are relations, but not all relations are functions. So a function is a special type of relationship where your domain values do not repeat. Your domain values do not repeat. Okay, how can I put this? Okay, all intro students are math students, but not all math students take intro. Does that make sense? All students at R.D. Parker have to take math, right? Everybody agree with that?
Yeah.
But so everybody in R.D. Parker is a math student. But not everyone takes intro. So intro students are math students, but not all students are intro students. I don't know if that's kind of a bad one. There's all kinds of them. I'm just trying to think of one that's going to make the most sense. So every function is a relationship, but not all relations are functions, because functions have special criteria of them. Okay, so each ordered pair, so this is how you check to see if something is a function. Each ordered pair has a different first element. So all the numbers are different in that first set. All the elements in the first column are different. And there's only one arrow in an arrow diagram from an element in the first circle. Okay, you ready? So we're going to say, is it a function or not a function? So this is A and this is B. So this would be my domain because it's set 1, and this would be my range here. So, oh, Rat, what do you need? What do you need? What can I do?
Set number B is the function.
Set number B is the function. And how did you figure that out?
You looked at the domain values, and I noticed that there are no arrows come out from there are no two arrows come out from the domain.
Right. So this one here is not a function. This one's here not a function because of this right here. How many arrows leave the number 2? 2. So that means that gets repeated. It means there's 2 wheels on a bicycle and there's 2 wheels on a motorcycle. So because of that element, we're not a function. Now, when you look at this domain, does any of this domain repeat? Are there more than one arrows leaving this domain? So there's no repeats in the domain, so this one is a function. Okay, so this one's not a function because the number 2 repeats. This one is a function because nothing in the domain repeats. So remember that your domain is your first set. Okay, let's go down to this ordered pair one. So this is like example C. Is this a function?
No,
Why?
because there are repeats in the domain.
Okay, what are the repeats in the domain?
3.
3. So in the first set, we see that 3 happens twice. So this is not a function. Okay, so the 3 repeats in the domain. So remember that the first set gets repeated. And you did this yesterday. That's why you broke down. That was the purpose of doing yesterday's assignment. You took the information from a table and you put it into the ordered pairs. So we know if we were to put this back in a table, it would be 1, 2, 3, 3, 4, and then green, orange, purple, red, violet, right? Like that would be what we would do based off yesterday. Okay, so now we're trying to figure out whether they're functions or not functions. Okay, let's look at this one. In a relation, so if we don't know it's a function yet, we always just call it a relation. It's just like, hey, this is some sort of relationship. We want to know if it's a special relationship called a function. The relationship that associates given shapes with the number of right angles in the shape. So right triangle has one 90-degree angle in it. An acute triangle has no 90-degree angles in it. A square has 4 90-degree angles in it. A rectangle has 4, and a regular hexagon has none. Okay, is this relation a function?
Yes.
Yes. Because you guys all would agree that set 1, or the domain in this case are the types of shapes. Right? So that yellow that I just highlighted there, those are my domain. So we're always checking the domain. So those are the domain. And we would say that, yes, this is a function because the domain does not repeat. So it almost should have been like I put these questions in the different order. State the domain and range of this relation. So, well, we know it's a function now because we know that the domain doesn't repeat. So we're going to do D colon fancy bracket. Oh, that's a terrible fancy bracket. And we're going to write them out. So right angle, acute triangle, square, rectangle, well, this one, regular, hexagon, and I've gone off the page. That says hexagon, I promise. And then I close with a fancy bracket. I hope your fancy brackets are getting better. So the range, what's the range for this one? Those are just going to be the numbers, right? And remember that I don't repeat numbers. I only have to write them once, and I should put them in ascending order. So what number am I going to put down first? What's ascending? So smallest to biggest.
1, 0.
0 first. And how many zeros do I have?
2.
I've got 2. So I only have to write it once. And then what comes next?
4.
1.
1. So right. 0, 1, 2, 3, 4.
And that 4 is stated twice, but I only need to write it once. Which is kind of nice, but so many words in this. Okay, so the next example, is this one a function or not a function?
Not a function.
How come?
1 and 4.
Exactly. Because the ones repeat, the 1 goes to -1, and the 1 goes to +1, and the 4 goes to -2, and the 4 goes to +2. So if you see many arrows, multiple arrows coming out of one number, you know it's not a function. It is okay if your range repeats. It's okay if your range repeats. There's no problem there. It's your domain that matters. Still can be a function. It's all about the domain in this one. Okay, this is nice and easy. State the domain and range of this relationship. So domain, fancy brackets. This is nice because in an arrow diagram, they don't write them repeatedly. So this is going to be 1, 4, and 9. Close my fancy brackets. R, going to open fancy brackets, and I'm going to have -3, -2, -1, 1, and 2, and close my fancy brackets. Oh, so much easier than the polynomials. So much easier than factoring. Domain and range.
I like it.
Okay, and that's it for today's lesson. I feel like we're slacking a little bit.